I saw this question on YouTube. Now it is given this find that. Well, it's quite complicated. It's not that easy. Z is a complex number. Now, how do we start? Now, okay, I have a different way of approach, so it's worth sharing here. Now, I consider Z seventh minus one, Z seventh power minus one could be factored as a Z minus one, and then times Z6 plus Z fifth plus Z fourth plus Z third plus Z squared plus Z plus 1. Well, that's easy to factor, right? You divide this by Z minus 1 because 1 is a root. So then you get the other factor. Well, since this equal to 0 as given, so the whole thing is 0, which means that Z seventh minus 1 is 0. So Z seventh is equal to 1, isn't it? Which means Z is equal to seventh root over 1. That is something which is very interesting. Okay, so this one is equal to e to the I 2 pi minus 7k. Well, k equal to 0, 1, 2 until 6, right? Yeah, k, this k. Well, which means that z is equal to is equal to 1 when k equal to 0. And when k equal to 1, this is a cosine 2 pi over 7 plus or minus I sine 2 pi over 7. And when k equal to 2, this will be cosine 4 pi over 7, right? Plus I sine 4 pi over 7. Yeah. Then there's another one, cosine 6 pi over 7 plus or minus I sine 6 pi over 7. So you have a 7 roots. Now if I use unicircle, I can show these 7 roots, right? This is unicircle, radius equal to 1. This is a 1 root. The other 6 roots just distributed over this unicircle equidistantly. So this is z first power, which is the argument is 2 pi over 7. And this is, okay, z square, that is this one, z third, the fourth, the fifth, the sixth. But these are just the conjugate of 1, 2, 3, you know? So z6 is actually z minus 1, z minus 1th power, z minus 2, this is minus 3, you know? This is the same because the complex roots is always conjugate. Why? why conjugate? Always conjugate, because the complex roots coming from irreducible quadratic factor, that is coming from this type of no, when this is a negative number, then you come up with complex roots. These always conjugate. You see, that is why the roots always conjugate, a pair of conjugates. Okay, that picture shows all 7 roots. Well, I think you must have done that in complex numbers. Now then, something interesting. Well, we are given this. Therefore, from here, plus to z6 will be equal to -1, which means that the real part of z plus z squared plus z3 plus z4 plus z5 plus z6 is equal to -1. Okay, let me separate the pictures. Yeah, okay. Okay, those are complex numbers, those are roots. The sum of a real part is -1. Yeah, obviously this is and the real part of this this. Well, read this z1 z first part, right? Sorry, z squared, that is this one, z third, this and that just split into this equal to this equal to this equal to this. Therefore, this one equal to a -1/2, because the the 6 numbers, the real part is -1, and the half of it must be -1/2. Since z cubed is equal to z fourth, these two numbers, these two roots, the real part is the same. Therefore, the real part of z plus z2 plus z4 is equal to -1/2, because they are equal, the real parts. Okay. And we are looking for that, right? We know the real part. We just need to find the complex part. We just need to find the imaginary part. I'm sorry. So this is the real part, and we just need to find the imaginary part. And then we find the sum. And we suppose that imaginary part is equal to imaginary part z1, z squared, z fourth is equal to bi. Okay. Yeah. And this, the sum of a real part, imaginary part, is equal to this, and that, right? Imaginary part Z3 this plus imaginary part Z5 plus Z6 is equal to negative BI. Well, you see the picture explains everything. This complex number, this complex number, the imaginary parts, the sum is equal to negative of this, and that. Because of these two complex numbers, the imaginary part just equal, but different sign, a positive and negative. This number and that number, the real imaginary part is the same, but negative. Okay, opposite sign. This one, same number, but one positive, one negative. This is the reason, no? Okay. Therefore, Z1, this Z4, the real part is the negative half. Imaginary part is BI. Okay. And the remaining B3, Z3, Z cube, Z fifth plus Z6. The other three numbers, the imaginary part is a negative half. The real part is negative half. The imaginary part is BI, negative BI. I'm sorry. Makes sense? Yeah. The real part, these three numbers, the real part is a negative one. That is this. The sum of the real part is negative one. So this, the sum, the real part is also. So let me write this one. The real part of 1, 2, 4. The other part is 1, is a 3, 5, 6. 3, 5, 6 is equal to negative half, right? Yeah, because this number and that number, the real part is the same. It's for cosine same. This number and that number, the real part is the same. This number, that number. And the Z and the Z6, these numbers are the same. The real part. See, that is, come up with that. Then we multiply Z2 plus Z4, multiply by this, Z3, Z5, Z6 will be equal to this time then, minus half plus BI times minus half minus BI. So this side is what? This side is equal to Z4, Z5, Z6, Z7, Z7 equal to 1. So this time that one is a 1. Now then this one time this one is a Z fifth. This one time this is a Z7th is 1. This time is the Z8th. Z8th is what? This is Z7. This is Z1. Okay. This one time this one is a Z8th power. Z8th power is same as Z1. Because Z 1, 2, 3, 4, 5, 6, 7, 8. So that's come back because the periodic. And then where are we now? This one time this one is 1. This one time this one is Z 9th, which is Z squared. This one time this one Z 10th is Z3. Then this is equal to 1/4 plus B squared. Yeah. And this will be 1, 2, 3 is a 3, right? 3. Z second, 3, 4, 5, 6 is equal to -1. See? Because the sum of these z's is equal to -1. Is equal to 1/4 plus B squared. So this is the reason I'm going to be equal to B squared. Okay, B squared equal to 7 over 4, right? 7 over 4. So B is equal to root over 2. Okay, so we find finally we find a Z plus a Z2 plus a Z4 is equal to -12 plus I 7 over 2. Yeah. Okay. So finally we find this. There's root 7 over 2. Well, this picture, that graph, it really helps. It explains everything. Thank you.